Before we talk much more about the arithmetic of complex numbers, we'd like to talk a little bit about the arithmetic of square roots in general. And there are some simple rules that square roots follow in arithmetic. In adding and subtracting, square roots act like variables. We can combine like radicals. Unlike radicals, we just have to leave. So, for example, if I have 2 root 5 plus 4 root 5, I can combine those to get 6 root 5. On the other hand, if I have 3 root 2 plus 5 root 7, I can't simplify. Why? Because 2 and 7 are different. Multiplication and division is a little bit nicer. In multiplying or dividing, we can use the fact that multiplying and then taking the square root is the same as taking the square root and then multiplying. Dividing and then taking the square root is the same as taking the square root and then dividing. So, for example, if I want to multiply the square root of 5 times the square root of 7, I get the square root of 35. If I multiply the square root of 8 times the square root of 2, I get the square root of 16. Since 16 happens to be a perfect square, that's just 4. As we see here, sometimes we can simplify after we multiply or divide. So, suppose that I asked you to simplify this expression as much as possible. For the most part, we treat the square roots like variables. So, since I can't combine anything here, I'm just going to multiply this as if it were two binomials. 3 times 4 root 2, that'll be 12 root 2. 3 times negative 2 root 3, that'll be minus 6 root 3. 2 root 6 times 4 root 2, that'll be 2 times 4 is 8, root 6 times 2. Remember, we're allowed to multiply square roots following this rule. Minus 2 times 2 is 4, root 6 times 3. So now let's see how much we can simplify this. 12 root 2 hangs out for now. Minus 6 root 3 plus 8 root 12 minus 4 root 18. A little bit of arithmetic shows us that 12 and 18 both have perfect square factors. Root 12 is root 4 times root 3. Root 18 is root 9 times root 2. But root 4 is 2, and root 9 is 3. So we'll have 12 root 2 minus 6 root 3 plus 8 times 2 is 16 root 3 minus 4 times 3 is 12 root 2. And now we're going to combine the like radicals. I'm going to write the like radicals next to each other so it's easy to see. 12 root 2 minus 12 root 2 minus 6 root 3 plus 16 root 3. So I have 12 root 2 minus 12 root 2. That'll be 0 root 2. Minus 6 root 3 plus 16 root 3. That'll be 10 root 3. Of course, 0 root 2 is just 0. So I'm just left with 10 root 3. That simplified a lot. It typically won't work out this nicely. But I'm going to give you one of these to try as well. Simplify this expression as much as possible. Pause the video and try this now. Alright, so supposing we don't simplify anything before we begin, what will we have here? Well, we'll have 4 root 3 times 2 root 5 So we'll have 4 times 2 is 8. Root 3 times root 5 is root 3 times 5. 4 times 3 is 12. Root 3 times root 3 is root 3 times 3. Minus root 5 thirds times 2 root 5. That'll be 2 root 5 thirds times 5. Minus 3 root 5 thirds times 3. All right, what can we do here? Well, 5 times 3 is 15. Not much else we can do there. 8 root 15 plus 12. 3 times 3, that means 3 squared. The square root of 3 squared is certainly 3. We could find out that that's 9, and the square root of 9 is 3. Minus 2 root 5 thirds times 5 will be 25 thirds. 3 root 5 thirds times 3 will just be 5. All right. Now here I want to make my denominator a perfect square so I can simplify. I'll multiply my numerator and denominator both by 3. I'll get, so 8 root 15 stays put. 12 times 3 is 36. And then I've got 2 times root 25 times 3 over root 9 minus 3 root 5. And I'd like to write this as root 25 times root 3 because I noticed that 25 is a perfect square. 8 root 15 plus 36 minus 2 times 5 root 3 over 3 minus 3 root 5. 2 times 5 over 3 is going to be 10 thirds. So my final answer, noticing I don't have any like radicals, so I can't combine anything, it's going to be 8 root 15 plus 36 minus 10 thirds root 3 minus 3 root 5. Doesn't work out super nice for us. Sometimes there just isn't anything we can combine.